All right, so welcome to video 4B. And in this video, we're going to work again with some more properties of quadrilaterals. We already talked about the parallelogram in the last video. And in this one, we are going to talk about the trapezoid. I didn't put a little box under that one, so you're going to have to draw your own. So we are going to draw just a plain old trapezoid here and talk about some of its properties. So again, we've already said that it has to have one pair of parallel sides. Another property of the trapezoid is that these angles, top to bottom, or one each along the parallel sides, are supplementary again. So they add up to 180. So I think it's easier for you to see it with numbers in there. So I think I'm going to throw a 130 on that one and a 50 on this one. And again, if this is 89, then the one down here is 91 because they add up to 180 together. Now, it's not true that these ones along the parallel line add up to 180. You can see that. But it is true, again, still, just like with all quadrilaterals, that the sum of the angles is still 360 degrees. Now, if the trapezoid is isosceles, remember that means it has not only a pair of parallel sides, but it also has a pair of congruent legs. What's also true then is that the base angles are the same. So whatever this is, so is this. Whatever this is, so is this. And this property still holds, which means they add up to 180. So again, in this scenario here, if this was 50, then so is this. And then this is 130 because these neighbors here add up to 180, and so is this. And lastly, if it's isosceles, it doesn't hold for this one, but it does for this one. The diagonals are congruent. They don't bisect each other. You can see that this one up here looks a little shorter than this piece down on the bottom, but they are congruent. So let's write that down. The diagonals, let's just write diags, are congruent if it's isosceles. All right, so let's go use some of those properties over here. Find the measure of the angle indicated for each trapezoid. Well, this is not isosceles. It's not marked that way. This is not marked congruent to this. But I do know that for any trapezoid, those angles there, top to bottom, add up to 180 degrees. So to get angle question mark, I simply do 180 minus 65 degrees, and I get 115 degrees, and I am done. So done with angle question mark on that one. Let's move on to the next page. Grab my page turner here and see what we've got going on the next page. So we are still finding the measure of the indicated angle. Now right here, I've got an isosceles trapezoid. This is then 120. Actually, I could even label all of these now. Since it's isosceles, the base angles are congruent. The neighbors add up to 180. Either way, question mark is 120 degrees. Find the length of the diagonal indicated. It says KM is 22, so I'm going to draw that in red. KM in red, JL in blue. Because this is isosceles and is indicated by these little double dashes here, it means those are the same. The diagonals are congruent. So JL is also of length 22, using the properties of the trapezoid. Now, off on the side here, let's talk about the median. The median connects the midpoints of the two legs right here. So you've got your parallel sides. Those are actually called bases. And then we've got the other non-parallel sides, and those are called legs. A median is in the middle of each leg. So a median is the midpoint. It connects, let's do this, connects midpoints of the legs. So a couple things you know if they say that's a median. You know this is the same as this and this is the same as this. But furthermore, there's a relationship between its length and the other two. And it's this. The median, you might want to put this in a box because I forgot to put a big box on here. The median is equal to the average of the two bases. So I'm going to erase all my stuff on here. Here's a base length, here's a base length. The median is equal to the average, which is what you get when you add them up and divide by 2, which is 10. So this one right here will be 10. It's the average. Oh, that's not true. That's going to be 22 over 2, which is 11. I could tell because I've got the average would be a same distance from one as to the other. So I made an arithmetic mistake there. But either way, the median is equal to the average of the other two lengths. Sometimes it's easiest to kind of think of that twice. Let's write another little sub thing here. Twice the median equals the sum of these two, which might be easier to think of. It equals base plus base. And I'm trying to do this without variables because I think that clouds the issue here. So let's go take a look at this one. It says find the length of the base. That's this one. Well, what I know is that this is the average of the other two. So if I do twice the median, it's going to equal the sum of the two bases. That's equivalent. Now watch, I could have used this top one and said that that's the case, that the median is the average of the other two, but then to undo this division by 2, I'd still have to multiply. So I'd still have to say 19 times 2 is equal to 13 plus question mark. So that leaves me to 38 is equal to 13 plus question mark. I subtract 13, and I get 25 is equal to question mark 25. Now, although that's how it says to do it, let me give you a little heads up here. Sometimes we can use common sense and it's a lot easier. See how there's a gap of 6 here? Then for that to be the median middle length, if I go 6 more, I would average it out. So sometimes you can use a little common sense, but any of those 3 ways will suffice. So let's go take a look at this one. What do I know? I know that this is the average of these two, but it's easier to say twice the median is going to be equal to the sum of the two base lengths. A lot easier because then I'm not working with a fraction. So I've got 58 over here on the left is equal to 25 plus 11x. I subtract the 25 and I get a nice 33 is equal to 11x. Dividing both sides by 11 gives me x of 3, and it just said to solve for x. So x would be 3 in that case. All right, let's go take a look at the next one. Find the measure of angle V right here. Well, what do I know here? These are all trapezoids because they told me. And this is an isosceles trapezoid because these are marked. For the isosceles trapezoid, opposite angles are congruent. So, well, what's the best way to put this? Let's go up and look at the picture so you can see the relationship up here. So I drew a picture up here. I'm going to scroll, see if it's still on here. You'll notice for the isosceles, I've got base angles of the same measure, and the opposite ones end up being supplementary. I think I misspoke. I said congruent, but the opposite angles are supplementary. So what I know is this one plus that one will equal 180 degrees. Let's go do that. Another way, too, is to put these base angles are the same. You could go like that, and then this one is another 5x plus 38, and you could say these two have to add up to 180. There's so many ways to do it, but we are just going to start off and say 12x minus 28 is equal to plus 5x plus 38 is equal to 180 degrees. And then again, we use some algebra. 17x, combining my like terms, plus 10 is equal to 180. 17x is equal to 170, giving me an x of 10. And it said to find the measure of angle V on this one. So make sure we answer the question asked, and I'm going to go plug it in here, and I get 5 times 10, which is 50, plus 38. So angle V is going to be 88 degrees. And actually, once I know one of them on the isosceles, I know all of them. That means this one down here is also 88, this one's 92, and this one's 92, because those ones next to each other there have to add up to 180 degrees. All right, so we're going to work with some areas here. Areas of triangles and quadrilaterals. Well, let's do one at a time here. For any triangle, whether it looks like this, and height is, I'm going to put an H on here, perpendicular to the base, or whether it's a right triangle like this with the height perpendicular to the base, we always say that the area is equal to 1/2 of the base times the height. Really, the reason why is you don't need to put this in your notes, but a rectangle's area is base times height, and the triangle takes up half of it. So for a triangle, 1/2, the base times the height. For a parallelogram, the area is just equal to the base times the height. But you have to be careful because if this is the base, the height has to be perpendicular to the base. So sometimes they'll drop it right here and call this the H. Sometimes they'll put it right in the middle. Sometimes they'll put it out here. But you have to make sure you're dropping that height or that altitude perpendicular to the base. But really you just do, let's put those in a box, base times height. And you might be asked for the area of a kite. I'm not sure if you will be on your worksheet, but if so, I'm going to give it to you. The area of a kite is determined by its diagonal length. So I'm going to call that D1 for diagonal number 1 and D2 for diagonal number 2. The area is equal to 1/2 of the product D1 times D2. Let me talk about why. Again, you don't need to put this in your notes because it'll mess up your picture, but I like you to understand where things are coming from. I'm going to put my kite in a box. The area of this box is this length, base, which is D2, times this length, the height, which is D1. You can see that this kite takes up half the area of the box because what's in is out, what's in is out, what's in is out, what's in is out. So really the kite is half of the box. Kind of cool. So let's go find some areas. Base times height, 2 times 3.1, 6.2. We always label area squared because it's yards times yards or yards squared. Next, I have a triangle. Its area is 1/2 the product of its base times its height to that base. So 1/2 of the base times the height to that base. So I would do 1/2 of 2 times 3.8. And that's going to give me 3.8. I'd say, how does she do that in her head so quickly? Multiplication can be done in any order. So I just did 1/2 of 2, which is 1, and then times 3.8, so I could do it in my head. Now on the previous page, I forgot a quadrilateral, so we're going to go back and put it on there. I put the kite on there, but I forgot the trapezoid. Trapezoid we use a lot in higher levels of math. You'd be surprised. Let's put the area of the trapezoid on here as well. So for a trapezoid, what we've got, let's go draw a picture. And I'm going to make it non-isosceles because it doesn't matter, but I do need to make sure I have a pair of parallel sides. I'm going to go label some stuff on here. I'm going to call this base 1. I'm going to call this base 2. And the bases are the parallel sides. And then the height is the distance between the bases, which usually is put here. And sometimes inside of it, or I could have put it over here and called this the height. It doesn't matter. I'm just dropping perpendicular between the parallel bases. The area of a trapezoid is 1/2 of its height times the sum of its bases. And again, you get to use these notes on your test, so make sure they're rock solid. So last one up here, and then am I at a stop sign or do I keep going? Then I'm at a stop sign and the video's over. So last example, this is a trapezoid. Its area is going to be 1/2 times its height. Let's go find its height. That's this right here, the 8, times the sum of its bases. And formulas are nice. They're just like following a map. So I'm going to follow this map. It says I am supposed to find the height and plug it in. And the height was handed to me as an 8. Then I'm supposed to put base 1 and base 2 in and add them up. And it doesn't matter who's base 1 or base 2 because I'm just going to be adding them up. I go 29.4. I'm going to do my parentheses. All right, and in front of the parentheses, I really have a 4, so I really didn't need to go to my calculator right away. I can do some of that in my head. I'm really going to have 4.8 plus 29.4, which gives me 34.2, and then times 4. And I've got 136.8 square feet. And I'm done. So you guys have a good one. Next up, worksheet 4.4 and 4.5. On that one, before you start it, you should come up and say, LaRude, do I have to do all of them? And I'll let you know. Have a good one.